Well, why don't we go ahead and get started? Again, welcome to today's IWCS webinar. My name is Dave Choudhury, and I'm honored to be the CEO and Director of IWCS, and I'll be your moderator for today's event. We have an international audience from all around the world, so some of you are after hours or before hours, and we really appreciate you participating today. A few housekeeping items before we get started. As an attendee, you are part of a larger audience. So during the presentation, all participants will remain in listen-only mode. And as a reminder, this event is being recorded for rebroadcast. We encourage you to submit written questions at any time during the presentation using the chat panel on the right of your screen. After typing your questions in the space at the bottom, hit the send button, and your questions will be addressed, time permitting, at the end of the presentation. Our IWCS webinar series events is hosted by the Cable and Connectivity Industry Forum, which will be taking place this October in Providence, Rhode Island. Today, we welcome Mabud Choudhury, who is the Standards Manager for OFS in Massachusetts, USA. Mabud will be presenting his paper on glass optical fibers for Automotive Ethernet. Very, very important application for the future evolutions of automobiles. Mabud is the Standards Manager for OFS. He contributes to the IEEE 802.3 Ethernet, INCITS T11 fiber channel, and the IEC fiber standards. He's the Vice Chair for IEEE P 802.3 dB, the 100 gigabits per second, 200 gigabits per second, and the 400 gigabits per second short reach fiber task force. Mabud has a master's of science degree in mechanical engineering from Massachusetts Institute of Technology, and also received his bachelor's of science degree in mechanical engineering from Duke University. Mabud holds 32 US patents, and we appreciate his contributions to our industry. So we welcome Mabud to present at today's IWCS webinar series event. Mabud?
Thank you, Dave, for the introduction. And let me just start by thanking Dave and Michelle and everybody at IWCS, both for the opportunity to present this webinar. But we made this presentation at last year's IWCS forum, which was, in our age of COVID, virtual. I do want to say that I'm looking forward to the upcoming 2022 IWCS conference in Providence, Rhode Island. And I just want to take a moment to, again, thank IWCS specifically for having a session recognizing women in our industry. OFS will actually have two lead authors, Yi Sun, who's an IWCS veteran, and Devjani Bhattacharya will be presenting also. So everybody who's watching this webinar, go register. It should be a great conference this October. So for today, as Dave indicated, I'll be covering a presentation on glass optical fibers for Automotive Ethernet. It's a new application area, a new market for OM3 for glass optical fiber. My name is Mabud Choudhury from OFS. My co-authors are John Earnhardt, also with OFS, and Masato Shino, who's with Furukawa Electric and deals with a lot of the automotive work. Furukawa is also the parent company for OFS. So today, again, I'll be doing some background on Automotive Ethernet, some history, where it came from. A lot of the focus here is standards-based, what's going on in IEEE 802.3 Ethernet standard, ISO and IEC, as we develop these standards for glass optical fiber for automotive applications. Some background on VCSEL multimodal links, both in enterprise and data center networks, which forms the foundation for this work. The application of graded index glass optical fiber in harsh environment applications. The specific focus for this presentation will be in aerospace and avionics, which was sort of a leading area for using OM3, OM4 type fibers and also single mode fiber, and forms basically a foundation for what we'll be doing in automotive. And then some data on technical feasibility for automotive environments, which are quite challenging from a temperature, chemical, vibration perspective for OM3. That was presented in the IEEE P802.3 CZ task force, and the prior standard to that was called Omega's study group, and then a summary and some future work. So these are a couple of slides from a call for interest. So the way IEEE 802.3 works is the work starts with a group of people coming together and presenting why a project should be initiated within the 802.3 Ethernet community. And for automotive networking, the CFI, which goes back to March of 2019, there's a URL there. And as with actually a lot of Ethernet standards, there's a lot of useful information in these CFIs. They're all in the public domain. You can find them in the Ethernet website, 802.3 website. But from a networking perspective, automotive data networks started back in 1991 with things like CAN, 2001 with LVDS, then with MOST, and with FlexRay. And Ethernet started being adopted in the 2008 timeframe with higher and higher data rates. On the right, in terms of trends, what started with just a simple single port for onboard diagnostics, engine diagnostics, has steadily evolved in the number of ports and the number of applications that are driving that need. If you go all the way to the right where we are today, you see more and more ADAS type application, which is basically advanced driver assisted systems. So things like blind spot detection, lane detection, automated braking. And we're obviously evolving towards fully autonomous vehicles where the car becomes self-driving. There's also sort of, if you look at automobiles, it's a technology that goes back to Daimler, Mercedes-Benz, late 19th century invention. We're really coming up on sort of 100-year, sort of once in 100-year major changes in terms of the connectivity that's happening with cars, car-to-car communication via 5G, for example. As I mentioned, things going from more and more human-machine interface to being fully autonomous, which is happening across multiple products, but certainly happening in automobiles. Shared services, things like Uber and Lyft, but additional services like that. And electric vehicles. So, the internal combustion engine has served the industry well for many, many decades, over a century. And now, of course, electric vehicles are becoming more and more introduced and eventually dominant for this market. Also, in terms of the network within the automobile itself, within the vehicle, you had sort of bus type architectures, which is starting at the left. You've gone to sort of domain architectures and now increasingly to zone architectures. So as with lots of devices, what was basically a mechanical device has increasingly become a data networking device in addition to remaining a mechanical device. So this is, again, back to the comment I made about call for interest that happens in the IEEE process. So just, obviously can't see all the names here. But the one on the left was in March 2019 for the CY project, so P802.3 CY, which was dealing with electrical, so copper-based systems for essentially greater than 10 gig. So that has become, and I'll cover that in more detail, 25, 50, and 100 gig on 25 gig lanes over shielded copper single pair, balanced pair. So again, lots of wide support. IEEE actually is an interesting standard in that people participate as individual participants, but we indicate our affiliation and employer. So these are showing a lot of the OEMs, so the major car manufacturers that are supporting it, the systems folks, and the tier 1, tier 2 supporters, people on the fiber side, the connector side. The one on the right is for the project that's now P802.3 CZ, which is primarily what I'll be covering. And in that case, also there was wide support. So both the copper and fiber has large support. CZ was for anything greater than 1 gig on optical fiber. So I'll spend a little bit of time on this table. This shows what's happened in IEEE 802.3 in terms of automotive. I'll quickly, I'll try and do this fast. There's some key individuals here that I do want to recognize. We always talk about standards and data rates and so on. Steve Carlson is a person who's a leader in IEEE. George Zimmerman, another person that been chairing a lot of these task force, and Kristen Matthias, who's affiliated with BMW, was sort of 10 years ago instrumental in combining all the expertise that's in the automotive industry and coupling that with the expertise that's in the Ethernet ecosystem. That goes back 40 years. So there's a long history in Ethernet. There's a long history with using twisted pair and Ethernet for local area network and data center applications. So leveraging all of that has driven these standards. So those top two rows, 802.3 BP and 802.3 BW, for 1 gig and 100 meg over a single unshielded twisted pair, was launched and has been tremendously successful. Just one data point there, Broadcom last year announced that they've sold 300 million nodes of Ethernet ports that include these data rates and slightly higher speeds also. In 2014, there was an effort launched, and I'll mention the leaders there. Bob Groh, who's a former working group chair and a chair in Ethernet, Carlos Pardo and Ruben Perez Aranda, who are affiliated with Katie Pop, were some of the people who led an effort to get 1 gig over plastic optical fiber. This was step into plastic optical fiber with either 4 or 0 connectors in line, 15 and 40 meters. So that was the first fiber application, and that has been deployed, and there are OEMs that are using products based on that standard. Things progressed in terms of, it's an interesting that data rates went down to 10 megabits to look at reaches all the way up to 1 kilometer. So at that point, it's obviously not just automotive, it's for industrial applications, it's for intelligent building applications. So that's a standard that was developed, and most of these standards take anywhere from 2 to 5 years to develop. That's pretty much the normal cadence for Ethernet standards. Then the CH standard is one that introduced 2.5, 5, and 10 gigs, again over copper, for 4 inline connectors over 15 meters. In terms of what's current, and so these are the ones I just mentioned are published standards. In terms of what's current, these are task force. These are active projects that people are working on. So the 802.3 CY is a copper standard, as I mentioned before, that's looking at 25 gig lanes over 1, 2, and 4 pair shielded pair balanced cabling is the thing. So it'll get basically a 25G base T1, 50G base T2, and 100G base T4. The next one I have that I've highlighted in aqua, the color for OM3 and OM4, laser optimized multimode, is the standard that I'll be focusing on, which is the P802.3 CZ standard. And again, it was initiated in 2019. It has a forecast date of 2023 completion, and it actually covers 2.5, 5, 10, 25, and 50 gig over either 2 or 4 or 2 inline connectors and a 40-meter reach in all cases. That project actually was split recently, just May of this year, a couple of months ago. So there's now a new project, P802.3 DF, that's based on the same CFI, but the parts were split. So that project and that group of experts will look at a graded index plastic optical fiber, while CZ will specify a graded index glass optical fiber, specifically OM3. So in terms of sort of the use cases for multi-gig optical systems, why do you need optical? So the backbone is one of the reasons, going all the way up to, all the data rates, 2, 5, 10, 25, and 50 gig, smart antennas, cameras and sensors, display, and data loggers. So one of the interesting things, if you go fully autonomous, is that vehicles will need things that equivalent of what airplanes have in terms of black boxes. So if there is some sort of an event, that information can be logged and cataloged. So there's a need for higher and higher data rates for automotive applications. So from an optical, and generically, the advantage of that optical has over copper. And again, the expectation is we'll see copper, we'll see glass optical fiber, and we'll see plastic optical fiber at these higher data rates, depending on reach, depending on the number of connections you want to have. But optics and fiber in general has an advantage from EMC compatibility in terms of galvanic isolation. As you go to electric vehicles, that becomes more important. It can support higher data rates per lane. So what is happening in the standard is the 50 gig per lane is happening over only glass optical fiber. Both plastic optical fiber and copper are limited to 25 gigs per lane in the current work that's going on. It supports longer reaches up to 40 meters, so not obviously appropriate for passenger vehicles, but for certain buses and trucks, that longer reach is valuable. Fiber saves weight, and it has potentially lower latency and power. I didn't list this, but in the age of sort of higher energy costs, the notion of saving power, the notion of having something that's fundamentally a lower carbon footprint is another advantage that fiber and optical solutions have. In terms of market potential, I won't go through all of this, but it's a large, again, there's a lot of vehicles. There's more and more of these high-speed links that are needed per vehicle. What used to be sort of for the very high-end luxury cars, now these systems are deployed in entry-level vehicles. You get more and more of these systems coming in. And it's estimated that up to 700 million ports will be required per vehicle. So this is not just the optical piece, this is also the copper piece. And so again, it's a mix between the different things. And it does overlap with some of the 1 gig links that are already being deployed. So in terms of ISO has always been there in terms of standardizing the different automotive standards that have developed in the past, and also will be there as these 802.3 standards are developed in 802.3. So it's in basically SC32 under the TC22 group. There's working group 3 and working group 10 that's looking, SC31 is looking at the data communication piece of it, and SC32 is looking at the hardware side of it. So essentially the MAC, the PHY, the transceiver, the NDI, and then the optical cable and the harness overall. And there's a history, as I said, for ISO, for CAN, for FlexRay, for MOST, for standardizing these things. And if you look on the right, there's one for optical for 1 gigabit and essentially beyond 1 gig. That's work that's ongoing right now to standardize that from an ISO perspective. A specific ISO activity that was launched was ISO 24581. And again, what's shown here is the optical harness piece. So from the MDI, the connectors, the fiber, and the inline connectors, that basic link is being specified. And that work is, the proposals are in place. Work is actively being pursued there to make that standardization reality. From an IEC perspective, a lot of the work is happening under TC86, which is Fiber Optics Technical Committee. And there's a liaison between IEEE 802.3 and IEEE 802.3CZ. Vince Ferretti, who's affiliated with Corning, is the liaison for that. And so it's looking at high temperature fiber standards. For OM3, it's looking at EMB being specified at 980, centered at 980. So 970 to 990 is the range. Currently, the informative guidance for OM3 goes up to 953. So it's looking at that extrapolation and validating that within the standard. It's looking at a graded index plastic optical fiber and making sure that that's specified within the standard, any new cable designs, and also looking at essentially from a connector perspective, anything that's specified in SC86B, and in SC86C, the charter is to look at the transmitters, again, high temperature VCSEL reliability, harness test standards, and so on. So the foundation for that, as I mentioned, one of the key advantages of taking work and the expertise that comes from the automotive industry and marrying it to what happens in the Ethernet standard. So Ethernet, as I mentioned, goes back 40 years. Twisted pair is about 35 years ago. There were fiber standards about 30 years ago started being developed. And about 20 years ago, there was a lot of effort to look at VCSELs and multimode fiber, and specifically laser optimized multimode fiber. So a lot of experts across the industry looked at the right encircled flux launch conditions, looked at the way to characterize the bandwidth EMB with using DMD methodology. And so there's a 20-year history of having a high volume, reliable, interoperable, commercially successful solution. Again, like a lot of the work that happens in standards, we build on the work of a lot of experts that have contributed in these areas over not just years, but decades. So for 802.3CZ, that foundation with basically what's SR type optics, short reach optics for local area network and LAN, it can be leveraged. And for an application that has its own requirements in terms of temperature, in terms of reliability, in terms of being on all the time, essentially, there's certain specific requirements that automotive brings to the picture. So in terms of glass fiber, it's already been used in multiple industries already. So FTTX, or fiber to the home, in some cases, is a good example of where fiber has been reliable. You have technicians who have to operate in extreme conditions, sometimes after a storm and blizzards and during flooded areas and so on. Fiber has always been one of the more reliable media for that application. So the notion that fiber sort of is not suited, it's a little too fragile. There's literally years and decades of experience in that area. It's in industrial networks, in data services, medical applications. Sensing is a big one. So very, very high temperature sensing in oil exploration is done with fiber optics. And then the other key one where there's been a lot of sort of specialized, so relatively low volume, but very challenging environments is aerospace and defense. So I'll focus specifically on that area as a foundation for what we're going to be doing on automotive. So from just an OFS perspective, there's been a lot of history in this area. There's multi-fiber cables and rollable ribbon that's now being introduced in that market. It's high temperature graded index 50 micron OM4 that's been optimized, that's utilized in that market. There's a specific product here, Flight Links, that's designed for high temperature that can be single mode or graded index 50 micron fiber. So these are some of the latest things that we are currently introducing or have in the market already. So in terms of why avionics and aerospace, well, it started off being first used in very, very rigorous military applications. There's over 25 years of history there. So it's the backbone for the F-22, the F-16, the F-18 variants, the Joint Strike Fighter, which is the F-35. It's been retrofitted into multiple airframe upgrades. The initial commercial applications, Boeing Airbus, has been in in-flight entertainment systems. There's a proven success in generating further commercial implementation. And again, it's like every other area, it's pushing higher data rates, pushing higher density for that application. So some of the requirements in aerospace form a foundation because they're similar to automotive. And in fact, they're usually more stringent in aerospace than automotive, as you might imagine. So it's high reliability and long lifetime. It's a very wide operating temperature, minus 55 C to 125 C. In terms of what we're looking at automotive, there's a couple of grades. It's minus 40 to 125. For some of the optoelectronics for the fiber, it's minus 40 to 105 C. So it's within the range. It's not as wide a range as what you see in aerospace and defense. Tight bends, installation stresses, crush and clamping stresses, chemical resistant, flammability, smoke and toxicity are some of the things that you have to pass to qualify for that industry. So some of the data that was presented in CZ, again, to prove technical feasibility of glass optical fiber, was shock and cycling thermal testing, again, from minus 55 C to 165 degrees C, with the attenuation being less than 0.2 dB. In terms of thermal cycling, also very rigorous, with the attenuation being less than 0.35. For CZ, we're looking at, again, 4 inline connections or 2 inline collections. If you're at 50 gig, for 2.5, 5, and 10, it's 2.5 dB per connection. For 25 and 50 gig, it's 2 dB per connection. So these changes in temperature would have to be within those limits for qualifying the link in CZ. There's also a series of mechanical tests that are done in terms of cyclic flex, compression, and tensile load that was done to qualify for this aerospace application. And the other one is basically a link test, transmission test. And I mentioned Ruben Perez Arandes, one of the people from KDPOF, who's been a leader in this area. And I want to acknowledge his support in doing these link evaluations. So this is a OFS fiber that's currently used in the aerospace application OM3. And this was at 25 gig for 100 meters. So that's beyond the reach that we're looking for to sort of bracket looking at 50 gig up to 40 meters. We also actually, even though we're competitors in the marketplace, standards brings competitors together for the benefit of the industry. So some of the experts from Corning, this is John Abbott and Steve Swanson and some others, also provided some Corning fiber that showed the same link performance. So multiple suppliers showing the capability of OM3 for this application. So just in terms of summarizing where we're at, the technical work and feasibility and reliability of glass optical fiber for automotive based on SR optics. So we've got this foundational history with, again, lots of expertise over 20 years in 802.3 and Ethernet for VCSEL multimode and OM3 links. So that's a very well-established, very reliable and well-resourced multiple vendors, both on the fiber side. So that lots of experts from CommScope, Panduit, Corning, OFS, and then experts on the VCSEL side from Broadcom, 26 Finisar, have really established the credibility of these links and the commercial success of these links based on those standards. So glass optical fibers in aerospace and multiple harsh environments is another basis for the technical feasibility in automotive, and of course the contributions we've been making in the P802.3 CZ task force. So for future works, we will continue to make those contributions as ISO and IEC finalizes and develops these optical fiber standards for the fiber, for the cable, for the harness, for the connectors. We'll make those tests per those standards to verify the fiber itself. Depending on the vendor, will be some variant of what's high temperature for OM3 that'll be specific for automotive, which besides the technical aspect, I will quickly mention, has very, very tough economic realities. It's a very cost-sensitive industry, certainly more so than aerospace, on the military side or even on the commercial side. Then it's testing to the new IEC standards, the ISO TC22 SC32 Working Group 10 specifications. And then there's also, this is an industry where beyond what the standards require, they're OEMs. So basically the largest car manufacturers, there's GM in North America, Toyota in Japan, or BMW in Europe, for example, and lots of other OEMs tend to have OEM specific requirements to make sure that glass optical fibers are fully qualified. So with that, I'll wrap up my presentation and welcome any questions that people may have.
Mabud, thank you so much for that enlightening presentation. And I invite the audience to put your questions into the chat so that we can ask those questions to Mabud as time permits here at the end of his presentation. Mabud, for autonomous vehicles, obviously 100% reliability for the life of the car is sort of a requirement. How are we determining that incredible reliability requirement for the infrastructure of the car?
Correct, and that's again, it's an excellent question. I can tell you, for example, besides reliability, security is a huge aspect of this. So there's multiple standards bodies that are looking at that, and there's actually a huge part of autonomous is also the government regulations that are going to be imposed there. And so each country is setting a different sort of standard in that requirement. I think the US tends to be a little bit more open. So, you know, the Teslas of the world are plunging ahead. A market like Germany, for example, tends to be a little bit more stringent in what's allowed there. But to your point, and it's sort of true of vehicles in general, right? If you look at cars, the amount of technology that's in your vehicle, the one that you're driving today, that we sort of expect always to work, right, in a way that isn't necessarily the case with some other data networking products, is sort of remarkable. So the industry spends a lot of time. So, I mentioned that like IEEE worked 10 years ago. And so it's the work in that standardization, then it's the standardization within the OEM communities, the amount of testing that gets done that keeps implementing these things. But again, autonomous will be challenging. And my personal view is that when humans make an error, we sort of say, well, that's a human error, right? We kind of accept that. So non-autonomous vehicles have lots of reliability and safety issues that we've accepted. When it becomes that the vehicle is doing, the standards are higher, right? So it's basically, airplanes have done that. So other than takeoff and landing, and even that is pretty automated at this point with experts to take over. So cars will have to go down that path. It's at some level, technically, the technology is already here, but doing exactly what you said, how do you make it bulletproof? How do you make it guaranteed? It will be a challenge, I think, going forward. But standards is certainly a key part in regulations.
Hands-free and foot-free, on the gas pedal and the steering wheel, we now are our liabilities, if a dog runs out in front of a car, or heaven forbid anything that causes that vehicle to have to respond, is a challenge on the infrastructure to make sure that infrastructure is reliable. The next question, sort of similar, is are all of the systems and computer software, is that all contained on board, or is there data transmission externally to the vehicle that is also required for vehicle operation and even the autonomous control? Is it all on board?
So a lot of it. So there's a lot of it that's on board, of course. But one of the slides I had was this notion of car-to-car connectivity. It's 5G connectivity. So there are schemes out there where the car communicates with the road itself. So it's not simply on board. That's part of it. That's a large part of it. But there is increasingly that vehicles are one more connected device, as are every device, right? Your refrigerator is connected, your microwave's connected, everyth's connected.
Then you have data centers involved, right?
You do. So you have to deal with, it's part of the broader network. So if you look at some of the experts that are interested in this area, they're coming out of the wireless side and the 5G. That backhaul eventually has to be processed in a data center. And your car becomes a small network, you have 50 nodes, 100 nodes that's traveling all the time. And again, to both your questions, that has to be absolutely reliable and absolutely safe. Yeah. So definite challenges there. Okay.
On slide 20, I'm not sure if you want to go back to that, but on slide 20, how do you explain the sharp step in attenuation at roughly 50 hours?
I don't think I know that detailed question. This is essentially real data that was generated. I don't actually know that answer, so I'd have to get back to that individual. So let me just write that down.
And again, I will be providing Mabud's contact points at the end of the presentation, so you'll be able to reach out to him directly, and he can solicit answers from his colleagues as well. On slide 22, is the VCSEL included in the chamber as in heat?
Yes, so it's an overall temperature for that link. So the VCSEL source, it was part of it, as is the fiber. So it's looking at those temperature extremes of -40, 25, and 125 C, and making sure that eye closure doesn't occur for that entire link.
Good. What kind of strengthening member is used in this optical fiber application?
So, okay, I'm not sure specifically for this fiber type. I'd have to go check that. So that tends to be very, very application specific. So as I mentioned, some of these fibers today are being utilized in military applications, which are much more stringent in what's required. Some are in commercial, so it's not particularly that much more than other commercial applications. So it depends on the fiber. The key qualification that's different about this is that it's a higher temperature coating and a higher temperature jacketing that allows it to sustain much higher temperatures than most OM3, standard OM3 that you'd find in a LAN or data center type application. But it can be packaged in the full range of any other fiber based on what that need is.
Okay. What type of connectors are intended to be used in this application, and will there be a standard FC, SC, LC?
Yeah, so these ones were tested actually with an FC type connector because that's from a test set perspective what was used. But there are multiple experts from a range of companies that have developed connectors in the automotive space that are making proposals there. So that's an ongoing work in terms of the standardization work that'll happen in both IEC and the ISO standardization process. So that's still ongoing. And that's so, you know, right now we're forecasting a standard in sort of later 2023 period. So all of these things have to become standardized in that time frame. So it's still ongoing work.
Very good. Is the operation over single fiber using a different wavelength for TX and RX, or will it use two fibers for the TX and RX?
No, so this is not a BiDi or CoDi type situation. It is one wavelength for transmit receive, and one of the choices that was made, and this was actually quite debated within the group, was at what wavelength. So typically, for most applications today with multimode, 850 is the dominant wavelength. So there's a lot of backward compatibility there. There are things like BiDi and SWDM4 where that range is extended. So it tends to remain backward compatible to 850, but will extend out to either 910 or beyond. So if you look at the standardization process, OM5 was specifically, from a normative perspective, spec from 850 to 953. This informative for OM3 and OM4 of looking at that. In this case, the wavelength that was selected is 980. That's how we're going forward. So it's a longer wavelength than has been traditionally used. VCSELs sort of have a natural longer wavelength. The history of 850 is sort of long and complicated, but it goes back to some of the decisions that HP and CD lasers that put the standard at that wavelength in particular. Because there's no backward compatibility in the automotive application, it's a clean sheet of paper. 980 was selected because the argument was that it gives more reliability at that longer wavelength. And again, these VCSELs, because of the high temperature, will be tested in a way that commercial data center LAN applications don't have. There was a proposal, one of the experts, he's actually a colleague from one of the projects I'm on, Ramana Murthy from Broadcom, who proposed a very wideband proposal, 840 to 990, that you could operate in any of those wavelengths as a way to get in there. But what's been selected is 980.
Okay, a more general question. What are the pros and cons of plastic versus glass fibers? And again, you might want to just focus on automotive in this particular case.
Well, since I'm employed by OFS, glass is better. So it's a simple answer. So that was an easy one. So it's a challenging question. So as I mentioned, the first 1 gig standard, and the experts actually from there, I mentioned Carlos Pardo and Ruben Perez Randa, are affiliated with KD-POF. POF's in the name of that company. That was a step index fiber. It's got a larger core. So in terms of mechanical use and robustness, there's some advantages. And actually that standard, besides automotive, for certain countries like Spain, POF is used for home networking. So instead of using twisted pair, they'll use POF in terms of their home network, local area networks. So it's always had that relative advantage. Its disadvantage is in terms of its bandwidth and its capability. So for this project, it's looking at a graded index POF. So it's a new type of plastic optical fiber. It'll have to go through that certification. And one of the, again, without being too biased, trying to be somewhat unbiased about it, proving in what was done of making VCSELs and laser optimized multimode fiber, that literally the years, the experts that were there in that process. I'll quickly mention a couple of them because they're friends and colleagues. Rick Pimpinella from Panduit, John Abbott from Corning, Paul Colasar used to be with OFS and the CommScope. This is 20 years of expertise and work to make sure, and all the VCSEL experts on the other side, to make sure those launch conditions are in fact reliable, repeatable, interoperable. So multiple companies did that. So some of that proving in will have to be done with GI-POF. It's not to say that it can't be done, but it will take more time. So one of the reasons to separate the two projects was time to market. The view was that glass optical fiber, that standard, can be developed faster than the GI-POF standard. So and again, even though mechanically, sort of in terms of potential ease of use, of termination, there's some advantages for POF. What I mentioned, like in this presentation, is that OM3, OM4 have been used in lots of applications. So again, fiber to the home is a good application where even with single mode, people are very capable of utilizing these fibers in much more harsh environments than a factory where you're going to be installing cabling harness, for example.
In this automotive application, like a lot of other sensory applications, cameras and things like that, is there work also being done regarding hybrid copper and fiber cabling, whether it be with power or otherwise?
Yeah, so that has been considered. So there's not an active standard on that, but there are solutions that try and do just that. So if you asked me the question about GI-POF versus GI glass optical fiber, right? So there's differences there. I just quickly want to add one other thing. One of the thrusts for the glass optical fibers was to be able to span 2.5 to 50G with the same reach, slightly different, it's two connectors with 50G. So it's one platform. Once it's certified, will be used. The other thing, you don't normally think of cars being upgraded, but people are holding on to cars longer and longer. That just sort of, people have 20-year cars. So the ability to potentially swap out your ECU for some more capability on the same infrastructure has value. So that's there. So yeah, I mean, I think, copper, one of its advantages is the ability to carry power. So like PoE in the enterprise space, power over data link, POODLE, is a standard that's there that enables you to do both the data transmission as well as the power transmission in copper. In the case of fiber, there is some capability of fiber to carry power, but generally for the kind of power you're looking in an automobile, you would end up with a hybrid cable.
Yeah. Yeah, I think obviously a lot of work being done in IEEE and standards organizations, but are there specific test requirements for installations, such as automotive, and will it just be loss measurements as is done for enterprise installations, or is there some different mode because of the reliability requirement?
Yeah, so this is where it's a very different industry than, so even in data centers and LAN, so the work that, for example, TIA does or ISO does in the commercial building standards. In automotive, it tends to be OEM specific. So, there's some differences between North American, GM, Ford, Chrysler versus the European ones versus the Japanese ones. But there's specific requirements that the OEMs impose on what's there. These are, again, it's remarkable how widely they're deployed. These are factories around the world. The supply chains are huge. They really do expect a lot from their suppliers. It's quite specific. So some of those things will not be just what the standards requires, but it will be OEM specific on, how do you put a wiring harness into a car and test it.
Okay. Well, again, Mabud, thank you so much for presenting this very interesting topic, and certainly the information is going to be very, very important over the coming years as we perfect this technology in mobile transportation. Please note that I have provided the contact points should you wish to engage with Mabud and his team after today's event. Each of these IWCS webinar series presentation events are recorded and will be archived on the IWCS.org website. It normally takes a few weeks for these to be posted. But IWCS has the technical papers available, and this paper was presented at the IWCS 2021 event, the virtual event last October, and it was identified as paper 14-8. The IWCS webinar series will conduct technical paper presentation webinars along with some sponsored company events several times each month. Our next technical paper presentation webinar will be on Friday, July 15th at 10:30 a.m. Eastern USA time. Again, we appreciate all of you from around the world at various times of the day, and particularly those in Asia who are now well into the evening. So each of you will be receiving an announcement for this event. Please feel free to share the announcement with your colleagues so that they can join in and register as well. Before we conclude, can I check and see if there are any last minute questions? Michelle or Mabud, do you see any more in the chat?
So I have not been looking at chat. So let me
All right, no, that's good.
I think you covered them all.
All right, super. Okay.
And Dave, again, and Michelle, thank you very much to IWCS. I mentioned the importance of the work we do in standards. I think IWCS is another forum that really is valuable to our industry. So thank you. And everybody register for Providence, Rhode Island in October so we can continue this work. Yes,
please participate, and thank you, Mabud, for that. It's important also that we all recognize and thank our IWCS partner sponsors who greatly contribute to the success of our Cable and Connectivity Industry Forum. Without their strong leadership and generosity, we would not be able to bring these important technical innovations and information to you, as well as our global audience. So again, thank you to these leading suppliers in our industry for your support. And you will see that OFS is a prominent partner for us in IWCS. For over 70 years, IWCS Cable and Connectivity Industry Forum has been the recognized leader, as Mabud was saying, showcasing the new technologies, standards, and all aspects of applications in cable and connectivity products and processes. With perseverance and with confidence, we're excited that our 71st annual Cable and Connectivity Industry Forum will now take place live on Monday through Thursday, October 10th through the 13th, 2022, in the Rhode Island Convention Center in Providence, Rhode Island, USA. Please watch your inbox and monitor social media as well as our website to learn more as the exciting information becomes available. And visit IWCS.org for more event details. The program is now coming into focus, and we're very excited about that. So again, thank you for participating, and this concludes today's webinar event.